session on parallel processing in PowerShell. If you want to hear about something else, you should be somewhere else. Name's Richard Siddaway. I know some of you by sight. I know some of you by name. I've known some of you for too long. I've been around the PowerShell community, some would say for far too long, since version 1 and the public beta 1. Started the first PowerShell user group in the UK way back in the day, which some of you I recognize from. I wrote my first program in 1970. No, I'm not that old. I'm just precocious. Did a lot of work on the PowerShell Summit. Been a PowerShell MVP, blogger, speaker, author. Please buy the books. My children like to eat. Currently working on a PowerShell 7 book, which will be out sometime next year, maybe. Assuming we ever get the final product to work on. Please feel free to ask questions as we go. If we can make this a more interactive session and get a bit of discussion going, that would be good. Oh, that's too technical. I'll put the slides and the demo code up on GitHub. It's under my full name, Richard Siddaway. You'll be able to find it. Questions as we go. I may postpone answering them if it's something that's going to come up later on. This is something that I just couldn't resist. How many of you were here last year? Yeah. If you remember, I did the keynote last year, and I showed this quote. From Steve Lee of the PowerShell team. The intent is never to have a PowerShell v7. Guess what? This year, the majority of the demos will be running on PowerShell v7. What a difference 12 months makes. Okay, so why parallel processing? Why are you interested in doing things in parallel? As you've come into this session, you've obviously got an interest in doing things in parallel. So why? What do you want out of parallel processing? Why do you think you need parallel processing?
I want to do 500 million DNS queries.
You want to do?
500 million.
500 million, all right. So you want to do a lot of stuff.
I did a lot of stuff.
All right, you did a lot of stuff. Well, come up and tell us. Anybody else?
I want to be able to build VMs and things from like a build VM script, but I want to build 5 of them in parallel because there's no dependencies.
Yep.
Why do I want to wait 2 hours?
Any other offers? I'll chuck another one in. There was a session 2-3 years ago by Chrissy Lemaire at the European conference about loading huge data tables into SQL Server. If you can, I think it's still up on YouTube. If it is, watch it. Especially watch the beginning if they didn't edit it off, as she watches a whole load of people walk in and she's muttering comments, not realizing the mic's on, about who's walking in. All of those things come down to one basic idea. Oh, I haven't a clue. It's the European conference. PowerShell. Go away. It's the. Sorry, Gail was poking his head around the door. Yeah, it's the PowerShell European conference. If you search on YouTube for it, you should find it. I think it wasn't last year, wasn't the year before. What was it? So where were we? 18, 17. It was probably 2016. It was a really, really good session. All of those things, doing the DNS queries, building the VMs, loading database tables, they all come down to one fundamental thing: speed. You want to get stuff done. You want to get a lot of stuff done, and you want to get it done quickly. And if you do it the normal way that people tend to think of 1, 2, 3, 4. It takes you a long time, and you don't have that time. So you're looking to speed things up. If you can do stuff in parallel, in theory, it should run faster. Overall, the individual bits may take slightly longer because you've got resource contentions and things like that, but overall, you should get it done quicker. Things, normal administrative things that can lead you to needing parallel processing, environmental issues, the number of servers. If you have to go and do something on 10 servers, it can either take you a long time if you do it manually. If you're in this room, you shouldn't be doing it manually. If you're doing 10 servers, it's fairly easy to write a script that'll bang around 10 servers and do whatever. 100 takes a bit more time. 500, well, you're thinking about it. By the time you're in the thousands of servers, yeah, that's going to take a good bit of time. So you're looking for things in parallel. Your operational aspects, like your backup windows, whatever else is happening, new builds, all of those things can impact the time you've got to get stuff done. Auditors coming in and wanting server documentation is another good one. That is really good running in parallel because it works. The other thing to think about very, very carefully before you spend a lot of time working through stuff in parallel is the skills and mindset that you've got in your organization. That's not necessarily yours. It's who else will be using this script and scratching their head trying to understand what you've done. Because it won't necessarily be you, because people move on, different jobs, different organizations. Leaving the script from hell behind is not going to make you popular. Okay. This is not necessarily related to parallel processing, but it's a common phrase that you will hear, especially if you're a consultant. Anybody not heard this phrase in an organization they've gone into? Exactly. Right. Run away quickly. Okay. True story. Day one of a new job, I'd literally walked in, sat down at the desk, and there's a guy behind me. You know how techies get when they're muttering and the things aren't working and they're cursing? And it was particularly interesting because he was South African, so it was an interesting accent and it was some interesting words. Found out that he needed to check a large number of servers for a particular event. I had thought about it for a little while, showed him how to write the script, and he got the results fairly quick. So I didn't actually do that in parallel because I just wanted it quick and dirty, but that's actually going to form the basis of all the demos. Okay, so what options have we got in PowerShell for parallel processing? You could do some sort of manual stuff. So invoke command, you can give it an array of computer names and it tends to do some stuff in parallel. You can run manual instances of PowerShell. You can batch up the processing. They work, but the multiple instances and the batching up, they work, but they're kludges and they get difficult to maintain. If you want, you're actually a single script that's going to do stuff in parallel. You've got a number of options. You've got PowerShell jobs. In PowerShell core, you've got ThreadJobs, which I'll cover off. You've got workflows. Hey, don't we all love those? Which is Windows PowerShell only, unfortunately, because all of the code has been ripped out of PowerShell 6 and 7. And if you watch the emails coming around from the project, they're quite gleeful. We ripped this out for workflows. It's all gone. PowerShell run spaces and the PoshRS jobs, which is a fantastic module with an awful name. And the last bit is for each object now has a parallel option as of PowerShell Core 7 Preview 3. That one's a work in progress, but it's there. Okay, I'm not going to cover every possible coding option because we'd be here till 5 o'clock tomorrow. I'm just going to show you enough to give you the flavors. And you can mix and match some of the options to, if you want to play around. As I said, I'll make the code available. You can play with it to your heart's content. But it's all as is. It works in my demo lab. Sorry. It worked yesterday in my demo lab. I'm hoping it'll work today. There's nothing more embarrassing than standing up here and your demo goes, but it should be fairly obvious if you want to play around with it. Okay, let's start with some manual processes. And this is basically what I'm doing. I've gone into some of the VMs in the lab and I've used write event log to stick a few particular events into the application log. So sequential processing, it's what everybody starts with. 99 times out of 100, you've got a job to do, you're going to approach it sequentially. Because it's the way we think, it's the way programming languages work. Even if you've got a loop, it's still a sequential thing because it's actually just concatenating a whole bunch of code. So we're going to get a bunch of computers. You could get them from a file, you could get them from AD. I'm just cheating and using the VMs that I've got running. For each loop, just going around, calling invoke command, script block to get the win event. Using win event because PowerShell core doesn't have get event log or any of the other event log commandlets, which makes life difficult. You notice that I'm using the VM name rather than computer name. It's because I'm using PowerShell direct rather than the WSMan. But the purposes of what we're doing, it doesn't make a heck of a difference whether I'm going over WSMan, SSH, PowerShell direct, or 2 bits of wet string. It's the concept of the parallel processing that I want to show you. And then I'm creating an object to output. If you don't like the way I'm doing the hash table and new object, tough, because that's the way I do it. Every time I post a blog and do that, somebody moans that you should do it this way or you should do it that way, or there. It works. Leave me alone. So let's. That goes off. It'll start plowing through the machines and it starts giving you the results back. Job done. Standard piece of administrative processing. 6 machines is nothing. You would actually do that sequentially. Building a lab with thousands of machines would take a little bit more than this machine's capable of, and you probably wouldn't sit here and watch it run. We'd never get finished. So that's how we approach that. If you want to start introducing a little bit of parallelization, you can start by giving computer name, VM name, the array of computers. And it will handle that for you to a certain degree. It's not necessarily the best parallelization in the world, but it gives you something, and it's a good starting point. And depending on the job and how long you've got for it to run and what you're actually trying to do, it's not a bad idea. By the way, can you see that code all right at the back? Okay, so that's, I'm only running these to prove that they actually work. But you would notice that that run significantly faster, and you get the results back. The other thing you could do is use the as job option. Anybody use that on invoke command? Yeah? Yeah. PowerShell v2, when jobs came in, the big ticket item was PowerShell remoting. That was the one everybody oohed and ahed over. And, but actually, PowerShell jobs and where they've gone, I think is probably as good as, if not better, for administrators. And I think it's an underused option. Now, let me scroll that up so you can see it. What have we got here? If you noticed, I had six computers, and I've got one job. Anybody know what's going on? Child jobs. So what happens when you use as job, and especially if you're running against a bunch of computers like we were here, is that you get one parent job and you get a separate child job for each of the machines that you're running against. Now, getting slightly ahead of myself, but PowerShell jobs, each of them will run in its own process. So they're running in parallel, and then they all come back. And you can not type properly. That doesn't work. So if you just try to pull the data back. So what you need to do is actually I'm just going to cheat because I'm not typing that. You need to actually select off the computer name and the count. But if you use the include child jobs, you get double the output. That's because it hits the parent job, automatically reads the child jobs, gives you the results, and then it goes through each of the child jobs. So always remember, if you're trying to get data out of something with child jobs, you just need that and just do it through the parent job. Unless you want to pick off the individual jobs as standard. And oh, yeah, I'll just show you. This is just to give you an indication of the sort of batch processing. So I'm just getting the computers and splitting them up, picking 2 off the array. I would really not recommend you do this. This is really just for completeness. The difficulty with doing this is it runs, it works, and if you do them off in separate processes, you get a degree of parallelization. But the difficulty is collating and concatenating all the results at the end. You'd have to write them out into a series of files and then pull them in and process them, and it's just too much work. So that's you could do. But again, it's an extra step. Whatever you do, it's an extra step that you have to take.
It's really complicated, really fast.
Yeah.
I've done similar things to this.
Yeah.
The problem, as you mentioned, with the multiple process is that if you're doing hundreds of thousands, then that can tank your machine in its own right.
Yep. Yep. Right. PowerShell jobs. Covered this already. Specifically designed for background execution. So you set it going, you get your prompt back, unless you use wait job for whatever bizarre reason you're working on that day, and spawns off a process per job, and it gives you the degree of parallelization. The problem with it, as the gentleman down here said, is that you run out of resources quite quickly if you overload the system. You can use scheduled jobs, but it's Windows PowerShell only. And it doesn't really work even using the Windows compatibility module. Actually, that's a second ironic moment that I should have put up. Why do we have a Windows compatibility module for a product that comes out of Windows? Don't get me started. Uses a separate process. Issues if you've got a load of jobs, picking off the ones you need to get the data, the resources you're using on the machine. Coding them can get interesting, especially if you want to use variables out of your parent scope. Anybody? You've obviously hit that. Two options. The argument list, and you put a parameter block in your script block that you feed into the job, or the using scope modifier, which is a much better way of doing it these days. If you're talking about going to remote machines, you've got a decision to make. Do you run the job on your local machine and connect off to the remote machines? Or do you run the jobs on the remote machine in like a fan-out process and then deal with it? So if you run locally, the advantages are that it's a bit easier to code and it's easier to manage and get your data back. The disadvantage is that unless you throttle things properly, you're going to overload your local machine and it's going to melt. The advantage of using the jobs on the remote machines is that you spread the processing across your environment. Yay! It's more difficult to manage because you've then got to go out to each of those individual machines and get the data back. It's one of those trade-offs that only you can decide on based on what you're trying to do and what your environment looks like. My recommendation would always be to start with the jobs running locally and fan them out if you need to, because you'll find it easier to manage and code. So, jobs. Okay, so we get our set of computers and we create a script block. You'll be sick of the sight of this script block by the end of today. And then I've just put a sleep in to give it long enough for the demo purposes. You wouldn't really want to do that. And then you start job, fire the job off. We've already answered that. The other ways to pass the values is to use the argument list. I prefer the using scope modifier. Is everybody aware of that? Yeah, well, you are now. It's much, much easier. It just tells it, head back up the scopes until you find the variable. Actually, I'm jumping ahead. Is everybody aware of scoping in PowerShell? and the impact of it. Okay, quick digression. You open a PowerShell console and think of that as the parent scope. You run a script, you run a function, you run a workflow, you do anything, it generates at least one other scope. Child scopes can see stuff in their parent scope. But the problem with jobs is it's in a separate process. So the one thing that they've done with PowerShell is stopped stuff going across processes, unless you do something like using the using so that as you build up the script block in compile the script block in inverted commas, lots of inverted commas because you don't really compile it, it actually grabs the values and uses them. So it's not actually crossing the process boundaries, it's bundling the stuff up to pass across into the new process, which is a good layman's way of describing it. The devs working on the code will probably run away screaming at that explanation, but it works for me. Sorry, did we finish looking at the code? Yeah. So the way I've set this is one background job per machine that I'm hitting. You could actually combine this with the sort of batch processing concept and use each job for a number of machines. That would be a good way to balance resources against the machines that you want to access.
Sorry, quick question. The IDs, 24, 26, 28, where are they numerically?
Child jobs.
Okay, so
there is always a child job. There is always one parent job and one child job, even if it's just a single job running against a single machine. You will always find at least one parent job and one child job. That's why the numbers go up in twos. That's all completed, and we just do the standard. I really wish that they'd set keep as the default. Actually, must put that into the default parameters. You all know about default parameters? Yeah, great things. I need to add that in. You can use the select to make that pretty and whatever. How we doing for time? We have got till 3 o'clock, haven't we? I think that's it for jobs. Yeah, that's just looking at the jobs. And that's going to be ThreadJobs, which we'll do next. Okay, ThreadJobs. They are PowerShell core only. They appeared in, I think it was 6.2. In standard PowerShell job, the job runs in a separate process. So it spins up a new instance of PowerShell in the background, runs the job, and then shuts it down. So if you go off to run a set of jobs, go off to a separate terminal and watch the processes, you can see them come and go. ThreadJobs, each job runs on a separate thread. You all know what a thread is in the CPU? Great. So, less resources needed because you're not spinning up a new instance of PowerShell. You still have the same issues about resources because you banging more threads through the CPU, but you don't need the memory overheads of the separate instances. Coding and variable issues still remain. There's throttle limit to limit the number of threads you're hitting. The last one at the bottom is the biggie. Because they're all in the same process, and because they're threads all running in the same process, if one of your jobs crashes, it can bring the lot down. Kaboom. Something to bear in mind. Other than that, they're fantastic. And they are very, very similar to jobs. It's one of those evolutionary steps in PowerShell that all you need is that little bit extra and everything else works off what you know. So, ThreadJobs, if you look at the code we're using and you can remember back to what we did for jobs, you will see that the only real difference is the start thread job. And that's just telling it to use a thread job rather than a background job. Just want to show you. Notice the type name is background job. This very handily gives you a thread job. The reason the last one hasn't started is there's a throttle limit on thread job with a default of 5. So by default, it'll start 5 jobs running. The 6th one and above have to wait until one of the jobs clears off and then it'll run. They will take a little while to run. Any questions on thread jobs while we're, or anything else so far?
So this is a safer general approach. You don't find it crashing everything and just it will auto-throttle itself.
Yeah. Yeah. The throttle limit parameter is exposed, which I think I'll show next. So you can set that to a value that works for you, depending on how many CPUs and cores and memory you've got in your box. This is getting there. So they've all finished. The great thing about thread jobs is you only need to know that one extra commandlet. All of the management for the jobs after that uses the standard job commandlets. Sorry.
So what would you define as a crash? Is that like a throw and exit, or is that something much more fundamental?
If it's something more fundamental. If a job throws a terminating error within the job just stops. And it will hold the error within the job. It's something that has caused that thread to crash, not the job itself. But if the thread crashes or something happens to the thread, that can bring down everything. And again, it's the standard thing. If you're working with PowerShell Core, how many people are working with PowerShell Core on Windows? Okay, yeah. If you're using PowerShell Core and you want to use jobs, have a look at thread jobs. If it will solve your problem for you. I'm not saying that it will, but it's an option, and it's a relatively cheap option to use in terms of processes and resources. Anybody heard that? Yeah. Yeah. That's one of my favorite quotes. I actually heard that, I think it was at HP, and it was one of their major partners came out with it, which I think I upset him when I laughed. Anyway, yeah. Okay, PowerShell workflows. How many of you used workflows? How many of you like workflows? When I showed the book slide, the one in the middle, PowerShell in Action, that I did with Bruce Payette, the workflow chapter was interesting. His comments were choice. Basically, everybody agreed after the fact that workflows didn't quite turn out the way they wanted it. Anyway, they came out in PowerShell v3. I think there were workflows with a big ticket item in 3. I suppose personally I could argue that the sim commandlets were bigger. They're specifically designed for parallel execution. I would say that they weren't widely adopted after the initial burst of enthusiasm. And these days they're Windows PowerShell only, because all of the workflow code has been ripped out of PowerShell 6 and 7, mainly because .NET Core doesn't support the underlying .NET classes. Issues. These are the major ones. Most of the scripts that you write, you're using one or more the PowerShell commandlets. You've seen the little scripts I've shown you. I've used invoke command, I've used new object. With workflows, you're not actually calling those commandlets. You're calling workflow activities that have the same name as the commandlets and are basically proxying the commandlets or standing in for the commandlets. But, this is where it gets fun, not all commandlets have corresponding activities. And if you try to use a commandlet directly, it will give you a great sea of red saying this isn't a workflow activity, you cannot use this, go away, stop being naughty, and write yourself an inline script. There are some coding changes, particularly in parameter names. So things like computer name can become PS computer name. Joy. And variable scoping, we've already mentioned that in terms of using, depending on whether you're using an inline script or not, you've got different branches for the way that you scope the variables. So it's either $workflow blah or $using blah. The bottom line says it all. Lots of people got very, very confused with workflows. But they have some really useful functionality. Checkpointing. If you've got a long-running workflow, you can checkpoint it, save the state of the workflow, including the results you've got to date. You can suspend and resume them. So if you suddenly need access to those resources, you can pause it and then set it going again. That's only true if you're running it as a job. Sorry, just remember that. They survive reboots. So if your remote machine that you're working against needs to reboot as part of the processing, the workflow will wait for it to come back. Because depending on how you actually code it, if you connect across remoting to the remote machine, using the workflow remoting, you're going to a separate endpoint that only workflows use. And you can get them to survive a reboot of the machine that is running on. The documentation is incorrect, surprise, but it can be done. I think it tells you to use a scheduled job. You have to use a scheduled task in reality. That functionality would be really, really good to get back. Because if you're running a huge script, pulling a huge amount of data back, and it's going to run forever and a day, you don't want it to bomb 3/4 of the way through and you have to start again. You want to be able to feed that data out. If you're doing stuff where you need to reboot, if you can get the script to manage it itself rather than putting in whatever bodge you use, and I've probably tried most of them, to work out when that machine's back and available, it would be good. Right. Where am I going? VS Code. How many of you use VS Code? How many of you like VS Code? Yeah. It's not my favorite. Nope, sorry. Okay, workflows. So if you've not seen a workflow coded up before, here's one for your edification. Use the workflow keyword. If you took workflow out and put function in, it doesn't. That's about what it comes down to. Takes a parameter block, same as normal. I'm getting the computers. This is where it starts to branch. For each parallel. Which what it's going to do is it will spawn off for each of the computers in that array. It will run whatever you've got in that for each script block. It will run in parallel. And invoke command is one of those things that didn't become an activity. So you have to wrap it in an inline script. And then you've got the using option, the scope modifier, to get back to the variables that you want. Apart from that, it's simple. And it works. Let me pull that across a bit. Because have you noticed how many people use asterisks as their password? If you run it in the ISC, it gets you get a nice progress bar telling you what it's doing. The only reason I put it in ISC is because VS Code complains like mad about workflow and everything else, and I can't be bothered dealing with it. So it runs, it's pretty quick, and it does the job. The overhead of the coding is something to think about, and the fact that they're not going to be present going forward is another thing to think about. I don't know whether you were in the remoting session previous to this, but it was mentioned that PowerShell 7 will eventually be shipping as part of the box, side by side with 5.1 initially, which leads you to the conclusion that eventually PowerShell X will replace 5.1. So core will eventually replace 5.1, in which case they will be gone. So if you're going to do them, if you're going to use workflows, think about the longevity of the code and how long you're going to need it for, because if 5.1 disappears while you still need that, you're going to be stuck.
So what version is this?
This is 5.1. Yeah, it's workflows appeared in V3. So if you're running V3 for 5 or 5.1, you've got access to workflows. They weren't in 6.0 or anything after that. I think in the early 6s, the code was present, but just switched off. And then they've ripped the code out since then.
Line 25, inline script syntax, is that just a workflow?
Yes. Yes. Yeah. Inline script and the parallel on the for each are workflow only parameters, keywords, whatever you want. Workflows, you've also got a parallel keyword. So you can put together a script block that it will run in parallel, and you'd use that if you've got a whole series of commands that you want to run in parallel, rather than here where I'm going out to a whole bunch of different machines. And there's a sequential keyword, so that if you absolutely have to run stuff sequentially, you can force it to do so. And you can mix and match and embed parallel blocks within sequential blocks, within inline script blocks, not within inline script blocks. You can embed inline script blocks within parallel or sequential, and it can get quite messy. Any questions on workflows? Okay, so if you can't use workflows, what are you going to do? One option is PowerShell run spaces. What you're doing here is using the PowerShell APIs to programmatically create and use a PowerShell instance in the background. It's not like a job where it spawns the whole process and does it for you. This you need to do yourself and code it. You will like it. It's great stuff. Head might explode, but you will like it. Honest, believe me. It's lower overheads than jobs. Honestly, if you're coding them yourself, it is more complex. The ideal is to create a pool of run spaces, so that, you know how you saw with the ThreadJobs, where you had the throttle limit. Basically, it's a similar sort of concept. So you create a pool of 5 run spaces. You start throwing work at them. When the first one's finished, it picks up the 6th job, or the 6th task, and carries on round. So you're reusing those resources. So in theory, the overhead should be lower. There's some shortcuts for the coding. So you can either be a masochist and type out the full class name, or you can use the shortcut accelerator. There is a way to make run spaces easier using the Posh RS job module from Boprox. Is he still an MVP? Yeah, quite long-standing PowerShell MVP. Good guy, knows his stuff. It is a good module. It's a solid module. It does run on Windows PowerShell and on Core. So if you want to go down the run spaces route, by all means, investigate them, coding it manually. It's always good to understand how things work under the hood. But if you don't want to go around that hassle all of the time, look at the module. I'll show you both as we go. So, using run spaces. Right. That's a warning for me, because on this machine with all of these VMs running and everything else I've got open, if I use more than 3 run spaces, I started getting issues. It's not a thing with run spaces, it's purely the physical environment that I've got here. Yes, sir?
What's the life cycle of this run space? When you create it, is it like globally accessible? So,
it's accessible within your script.
right, okay. So
You could, in theory, if you dot sourced all of this stuff, the run spaces would be accessible, and you could use them. When we get a bit further down, you might realize why you don't want to do that.
yeah. So you basically have to do the cleanup yourself.
Yes, yeah. If that's what you were leading around to, yes. when you create and use the run spaces, you have to tidy up after yourself. Two ways to do it properly, by using the dispose methods, or you can just shut down the PowerShell session, it'll all go away. I think eventually the .NET garbage collection should eventually clear them out, but it's not something that I'd want to.
It takes a while.
Yeah, it takes a long while.
It's kind of like patching the global scope, right?
Yeah. So, get the list of computers as normal. Just sorting them, so I'm throwing them at this code in alphabetical order. They should come back out of that order, which is hopefully proves that it is running parallel, or not, depending on how cynical you are. Get the credential. It's boring. I've done that before. Right, this is where we start. So we create a run space factory by using create run space pool. I'm creating this one with a minimum of 1 and a maximum of 3 run spaces. That's purely resource driven by this machine. If you're doing this, and I had all of that junk shut down, and I was actually just throwing the using this as a workstation and wasn't running VMs on it, that maximum number could be much higher. It's like jobs and anything else. As soon as you start hitting parallelization, you need to think about resource utilization. You need to create next an instance of PowerShell and link it to the run space pool. So that's what we're doing here. No, I'm not going through there because I'll rip everything off the table. So create an instance of PowerShell, link it to the run space table, open the run space pool. You now start building the script that you want to run. So you create an array list, which is slightly different to an array. Pipe in the computers for each object, and then you actually, that's daft. I've just realized, I've used this code several times. I've just realized I've done the PowerShell create outside and inside the loop, and I didn't need to do. Yes.
I found that code, I think, somewhere else, and thought, and then can I take this out?
Yes.
I did, and it still worked.
Yes. That's a long-running typo I've had in that code. You learn something new every day. Okay, so you create the PowerShell instance. That makes more sense. You create the PowerShell instance, and you're linking it to the run space pool. You now need to add the script to that PowerShell instance, telling it that we've got 2 parameters, which is the computer, which is coming from here, and the credential, which we created outside of the loop. The invoke command block is pretty much the same as before. The props is the same as before, and the new object will be the same as before. So that's our script. You now need to add your parameters. So the computer is coming from the for each loop using PS item, and the credential is coming from $cred, which is outside. You then begin invoke, which basically starts to kick the thing off. The next bit is to create a handle so that you can actually work with it, and you add that in, and then it goes around the loop and basically adds them all again. So I will set that going. You can view the progress by looking at the handle. So they're all completed. Run spaces are pretty quick. They're probably the fastest way to do stuff in parallel in terms of execution, and not the fastest in terms of coding up and testing and getting them to work, but in terms of execution, I think they're probably the fastest. Yes, sir?
Definitely help me with some code using run spaces. A DNS query has a period of time that it takes. 100,000 DNS queries takes a bit of time.
Yep.
100,000 DNS queries in a serial manner takes between 23 and 40 hours. Using run spaces, it's down to 2 hours.
Yeah. So your initial figure was 40 hours outside?
Somewhere between 23 and 40 hours.
All right.
Using an Azure B2 MS.
Okay, so let's say 33 as a 33 hours as a middling point, down to a couple of hours. Yeah. Using run spaces.
How many spaces you running that on?
It started with 4 and went up to 12.
Yeah. The session that Chrissy did, the European conference a few years ago that I mentioned, she was loading, I can't remember how many million rows into database tables, but she got it down to some ridiculous number of rows per minute she was loading with run spaces. Absolute stupid numbers in terms of the speed. So great for speed, bit complex for coding. Can you dynamically change the size of the pool? No, because it's set at creation.
But once it gets going, you don't want to touch the machine.
No.
If you touch the machine, that's it. Forget about
Yeah.
the data.
If you're going down this route with run spaces, do it, and as he said, leave hands off.
It would be quite useful to be able to start a call, say 10, look at the resource, and then say run 15.
Yeah.
15 resources to line packet.
Yeah, I think.
If you Google the community contribution, you'll find the sweet spot calculation set at number of processors +1. I'm not sure where it's coming from, but that's.
I would rather than processors, I would look at cores. Yeah, think about the number of cores you've got in your box, and use that as a starting point. And basically, the only way you can do it is test it and see what works for the job you're trying to do against the resources you've got on the machine. And it won't necessarily be the same for every task that you're trying to complete, unfortunately.
So some jobs are weight heavy, some jobs are memory heavy.
Yeah. Yeah. If they're weight heavy, that's fine because you can stick more in. As long as they're not all running, waiting, and then running. And then get the data back, and then as we discussed, you need to do a manual cleanup to get rid of the mess. Okay, run spaces. Any more questions on run spaces? Yes, sir.
Just so we can understand clearly, if we go up to the top of that code,
Yep.
and just clarify which bit you need to take out for the run space to work properly.
Okay. Well,
so you leave the bit inside before each.
Yeah, it's
Get rid of the top bit out.
it's those two lines.
Yeah. So you leave the PSA, you get rid of the PS.
Yep. Get rid of that, and get rid of that.
When you remove it from in the loop, you don't need to create a new PowerShell object for every computer.
Yeah, because you the way this is working is you're basically creating a PowerShell instance, putting the script into it to run, attaching it to the run space to run, and then it drops off the run space when it's finished, and you reuse that run space.
So there, aren't you creating a run space pool for every computer?
Yeah, but the run space. No, I'm creating 3 run spaces, and I've got 6 computers, so I'm reusing them.
Yeah, so line 16, you're initiating the kind of the overall container for
Yeah.
the run space,
Right.
and then the
Yep.
PSA, you're then injecting each one of those objects into that container.
Okay, yeah.
If you created 3 run spaces and you had 3,000 jobs to do,
Yeah.
does it queue them all up? Or
Yes.
when it gets to object number 4, wait until there's a full element available?
It will, if the question is, if you create 3 run spaces and you've got thousands of tasks to run through it, what happens to the from number 4 onwards? They basically queue up and will use the run spaces as they become available, and that is handled automatically within the code for you. You don't need to manually manage that yourself.
You have to worry if you had such a small pool and such a big amount of jobs.
Yes, I would.
You could completely crash the run space.
Yes.
Too many things.
Yeah, you would either look at another option, or you'd look at getting a bigger machine.
It is possible so that it can turn around and
Yeah, the issue that I was hitting when I ran more than 3 run spaces was that the server name was dropping out for some bizarre reason, and I found that if I dropped the numbers of run spaces, it worked properly. So it's a resources issue somewhere. I didn't have the time or inclination to actually track down where it is, but yeah, if your run space pool is very tiny compared to your workload, have a think as to whether run spaces is actually the right solution for you.
I was generating 100,000 DNS names, FQDNs, and feeding those into this run space. And the numbers that I had, it would crash for other reasons because I'm trying to load into the machine.
you try and check on it and it kill it.
So, you do things like that. I wasn't aware of how to check where it was, so I was using Netmon to find out where it was in the DNS group, and let it tell me roughly where it was in the list of DNS.
Okay, the PoshRS job module. As I said, awful name. I hate the contraction posh. It's one of my really pet peeves. I've always hated it. It basically gives you a set of functions that are analogous to the job commandlets. As you can see from there. To use them is okay. You get your list of computers, you pipe them in to start RS job. Please heed that warning. Do not use for each object, because you get 1 run space per object going around the pipeline. It's just one of the little fun things. I'm throttling this back to 3 just because of the issues I've been having. If you're doing this on a decent sized machine in your environment, you can run more than that. Okay, this bit where the computer's coming in as a parameter, this is a feature. Or bodge, depending on how you want to look at it, to pick up whatever's coming down the pipeline. I suspect that Bo couldn't think of another way of doing it and ended up doing like this, and it's working. The rest of that script block is as before, and that's it. So we'll This is why I never type and talk at the same time, because I can't do it. It's too technical.
Come to my session this afternoon.
Okay. So you see the throttle limit, 3 of them are run, the next 3 are running. And they will, because they're using run spaces, they're fairly quick. And one good thing that Bo has done is that by default, keep is enabled. Okay, we're nearly at the end of our fun-filled journey through parallel options, run spaces. I actually heard that. First day on a new job, and the team leader of the team I was put in said, "You'll never automate that." Yeah. Yeah. Guess who won? Okay. For each parallel. PowerShell v7 preview 3 it appeared in. We're now on preview 4, which came out this week. Just this last week, I think it was. It's basically a new parameter set on for each object. It's using run spaces in the background and the sort of way ThreadJobs does, and it's some clever stuff. Basically, the for each script block is running parallel. Default is 5 concurrent run spaces, throttle limit to control that. You can run it as jobs. There's a very good write-up from Paul, whatever his name is, that actually wrote the feature. It is an experimental feature. If you've not looked at the later iterations of PowerShell Core, they've introduced this concept of experimental features. So new stuff that may or may not break or may not be changed before it finally is released goes in as an experimental feature so they can get feedback on it. I think that is actually one of the best things they've done. It's a great idea. So, and so there's currently a bunch of experimental features available. So if your command's not found, it'll suggest answers for each parallel. Implicit remoting batching. Basically, if you all know what implicit remoting is. Yeah. Basically, if you're batching stuff up, it actually speeds that up. The ternary operator. Yeah. So a couple of debugging options and the desired state thing. I didn't actually show you the code, did I? I suppose that would be a good idea. So basically all you do is get your whatever it is you want to work with. Let me scroll that back up a sec. So I'm getting the VM names, sorting and selecting, and just piping it into for each object using the parallel option, and then the script block just works as a standard for each. So you can use PS item or $_, whichever is your personal preference, using to probably actually don't need, yes I do, because it's a run space. So need using to access the credential, and then it just goes off and works. And it's pretty quick, This job, it's still experimental, so there is a lot of discussion going on about a few ways to change it, but that's the gist of it. And you can use a throttle limit to control how many run spaces you're using at a time. As I said, default is 5. You pull it down to 3, or you can push it up if you wish. And you can run it as a job if you wish. It will run as a single job, and it will go off and manage all the run spaces in the background for you. Actually, I will run that one because it will show you.
Does that create a batch of run spaces per job?
It creates one. Let me run that, and then it creates one job, and all of the run spaces are managed within that job. And I'm not sure whether you can see that or not, but it is a separate job type. But you can manage it. You can manage it with the job commandlets. You get this. You get this PowerShell exiting job come up, which doesn't appear to ever start and just sits there. I only noticed it not yesterday, Thursday, late Thursday. So I need to put an issue upon that to find out what's going on with that. But apart from that, it's just a single job. It manages all the run spaces within the job, and then you get your results back as normal. I'll just. Okay, we're nearly done.
One quick question on the code on that last one.
Yeah.
Is there any reason you're using PS item rather than $_?
Personal preference. If you watch or look at anything that I write, I tend to flip-flop between the two depending on what my mood is. Okay, we've covered this off. Use parallel processing, highly intensive scripts, need multi-core processors, set throttle limits where you can. If you need to wait for stuff, if you're waiting in parallel, that's all the better. Don't use parallel processing when you've got a trivial script just because it looks good and cool and gives you bragging rights. So which option out of all those? It depends, like everything else. Which PowerShell version are you running? If you're running 5.1, you've got options. If you're running 6 and 7, you've got other options. The coding complexity, that's based on your knowledge and skills. The maintainability is based on your organization's knowledge and skills. Because while you might be able to put something together using run spaces, can the guy who's going to take it over manage it? And the machine resources you've got. In that some options are more resource heavy than others. So finally, think about parallel processing, use it where appropriate, use the technology, let the systems do the work. We invented computers to do work for us, not to slave over them. Any questions? If not, lunchtime. Thank you very much for listening. Thank you very much for taking part and asking questions and discussion. Enjoy the rest of the day. Thank you very much.